Hi everyone, meteorologist Gary Woodall here, and welcome to this episode of the Mid-South Weather Musings. Today we're going to talk a little more about radar, look at reflectivity structures which might suggest severe weather. Stay tuned, the episode's coming right up. In the last episode of the Musings, we talked about some of the basics of weather radar, how weather radar works, some of the scanning strategies that are utilized, and some very basic information about the radar data that we receive. In today's episode, we're going to take a little more look now at the reflectivity data and some signatures that might suggest a storm that is showing up may have a potential for severe weather. So let's get on into it. Now, as a reminder, reflectivity is measured in a quantity called dBz. It's a logarithmic quantity. That probably isn't real important to you, but what is important is the color scale over here on, in this case, the left-hand side of the picture, the radar image, and that relates what dBz value represents what reflectivity value. Now, typically, reflectivity values may range as low as the teens or the 20s, up into the 60s and 70s even. High reflectivity values, if we see values in the mid to upper 50s, that can suggest very heavy rain. If we start seeing values in the 60s, maybe pushing 70, that could suggest possibly hail with the storm as well. Also, if we see a very tight reflectivity gradient, this will usually be on the south or the southeast flank of the storm, a very fast transition between no or very light return to very strong reflectivities, very high radar return over just maybe a couple of miles. That can suggest that the storm is very well organized, that we have a strong updraft and a strong downdraft next to each other with the storm. Now, radar samples the precipitation, the targets that are in the atmosphere. So typically, the updraft area of the storm will not have much radar return associated with it. And visually, if you're out watching the storm, this is where you would see the rain-free base, the updraft towers, other features suggesting the updraft area of the storm. So high reflectivity values, a sharp reflectivity gradient on the usually south or southeast, the inflow side of the storm, can suggest storms that are well organized and possibly strong or severe. If we see a curvature to the storm's echo on the south or southeast flank of the storm, sort of the kidney bean shape like we see with this particular storm, another sign suggesting potential storm strength or severity. This echo curvature may suggest that there is some rotation present within the storm, or at least some developing rotation that's trying to get going within the storm. This is an example of what's called a bow echo. And bow echoes form when we have an area of strong winds called a rear inflow jet that comes moving into the backside of the line of storms that we see here moving into southwest Missouri. Now, as those strong winds move in to the backside of the line, they'll accelerate a portion of this line forward and form this sort of bowed out shape like we see with the line here. Now, these strong winds in this rear inflow jet region will often be brought down to the surface, and bow echoes, as a result, have very strong straight line winds, damaging straight line winds, as the primary severe weather threat that can occur when we have a bow echo. We can sometimes get short-lived circulations that will form on the north end of the bow, and these can produce areas of enhanced wind damage or maybe even short-lived tornadoes. But again, the primary threat, the most widespread threat we'll be dealing with a bow echo will be the very strong straight-line winds as those rear inflow jet winds come into the back of the line and get brought down to the ground. This is an example of what's called a three-body scatter spike. A three-body scatter spike is a reflectivity flare that will show up and appear away, down radial, away from the radar, going out from a storm. This three-body scatter spike is usually seen with storms that have very high reflectivity values. This particular storm, greater than 70 dBz, the very light purples, and even approaching 75 dBz, the white areas that we see here. The three-body scatter spike suggests the presence of hail within the storm. Now, it doesn't necessarily tell us about the size of the hail. We could have some large hailstones or a large number of small hailstones when we see one of these three-body spikes. We have to look at some other details, some other information with the storm to tell for sure just what's taking place. So here's how we get a three-body scatter spike to occur. We have our radar here on the left and our storm with the hail area, hail up in the storm over here to the right. So what happens? The radar beam, the pulse of radio waves, excuse me, comes out from the antenna, and those radio waves will hit the hailstones. A portion of the radio waves will actually be deflected down toward the ground, then reflected back off of the ground, back to the hail, and then back to the radar. Now, the radar doesn't know that those radio waves made this extra trip down to the ground and back up to the hailstones. The radar assumes that the waves were just moving out as normal. So once this return from the this extra trip comes back to the radar assumes that those echoes, those targets, were actually out here somewhere. And that's what leads to that flare that we see that goes down radial out away from the storm and away from the radar. And then finally, of course, a reflectivity feature that a lot of us, I'm sure, are familiar with is the hook echo. Hook echoes have been seen on weather radars since at least the 1950s, and this is actually a picture from the April 3rd, 1974 super outbreak. This radar is near Cincinnati, Ohio, and we can see the hook echo here to the west-northwest of the radar site. In the early days, it was thought that the hook echo meant that the storm had a tornado. We've learned since that's not necessarily the case, that it may be more likely associated with a mesocyclone, with a supercell, not necessarily with a tornado. Hook echoes form when the mesocyclone, that large-scale circulation, takes some of the precipitation, the rain and hail, and wraps it around the western and the southern side of the circulation, leading to the figure 6 type shape, or sometimes the fishhook type shape that we might see, oftentimes on the south or southeast or southwest flank of the storm. And usually we will see the curvature of the storm and oftentimes a sharp reflectivity gradient in this area as well. And if we look at the hook echo as it evolves over time, or we look at some other data fields, some other details, some other information about that hook echo may become present and visible to us. One of these additional details that we may see is what's called a debris ball. You notice in the tightly wrapped up portion of this hook echo, a little spot of higher reflectivity in there. The dark reds and the bright pinks, higher reflectivity than we see in the rest of the hook echo. And that increased reflectivity is likely caused by debris, large targets for the radar to sample that have been picked up and lofted up into the air by a tornado. And of course, whether or not this is actually a debris ball, as it's called, can be confirmed by looking at dual polarization data, or if there are spotter reports from the area to confirm the presence of a tornado. But this debris ball does suggest that a tornado may be in progress here. And again, lifting debris up so that it can be detected by the radar. So that's going to wrap it up for this issue of the Mid-South Weather Musings. If you like this type of information, then follow us. If you're watching on YouTube, subscribe to our channel. If you're watching on Facebook, like and follow our page. That way you can be notified when we put out new episodes. And we will, in future episodes, talk about Doppler velocity data, dual polarization data as well. Now, if there are other topics that you'd like us to cover, make note of those in the comments section. We'll see if we can work those in to a future episode as well. Thank you all though so much for watching, and everybody keep safe.